In trigonometry, the sine rule, also known as the law of sines, is a formula that can be used to solve right-angled and non-right-angled triangles. So what exactly does this formula solve? By utilizing the formula, you can find the unknown sides and angles of a triangle. It works by relating the side lengths of a triangle to its sine of its corresponding angle. Before we get to the formula, let's first look at this triangle. As you can see here, the triangle is labeled with both capital and lowercase ABC. Capitals referring to the angles and lowercase referring to the side lengths. If we look at the position of angle A, it is directly opposite to side length A. And this goes the same for the rest of the sides. Finally, let's look at the sine rule. If we look at the variables used, they are the same ones as mentioned in the previous triangle. The rule states that when we divide side A by sine angle A, the fraction is equal to side B divided by sine angle of B, and so on. An alternative way to present this formula is the reciprocal form. Reciprocal meaning 1 divided by the value. These two formulas both deliver the same answer and ratio. So how does the sine rule actually work? Let's get into the proof of the sine law. Here we have triangle ABC that is split up in two smaller triangles at H, which is for height. In the first triangle, ABD, sine B will equal to H over C as opposite over hypotenuse. Therefore, H will equal to sine B times C. And in the other triangle, ACD, sine C will equal to H over B. Therefore, H will equal to sine C times B. Therefore, H equals to sine B times C, which also equals to sine C times B. Now that we have this equation, we can rearrange C and B to opposite sides and get part of this law of sines formula. Sine of angle B over B equals to sine of angle C over C. But where is the third part of the formula? Sine angle of A over A. To derive this is actually very simple. We use the exact same process but with either B or C. Now let's use the sine rule to solve some examples. In the example, we can see that we have a matching set of values for angle C and C. We also have the angle of A, but we don't have the side length of A. Let's begin this example by putting it into the sine rule. So that becomes A over sine 45 equal to 5 over sine 60. Because we are finding the value of A, we must first make A the subject, and that will become 5 over square root of 3 over 2 times 1 over the square root of 2. A will become 10 divided by square root of 6. If we put this value into the calculator, we get 4.08 to 2 decimal places. Now, for a harder example, prove that AD equals to 200 times sine 23 over sine 32. According to the figure, we are not given the angle size of A, however we are given the length of its corresponding side, which is 200 meters. We are also given the angle size of C at 23 and the side we need to prove, which is AD. In order to use the sine rule for this question, we must find the angle of A. To do this, we can start off by finding the angle of ADC. We do this by doing 180 minus 55, as this is the angle sum of a straight line. That results to 125. Now that we have angle ADC, we can use that to find the angle of DAC. We do this by doing 180 minus 125 minus 132, as this is the angle sum of a triangle. This equals to 32 degrees. Now that we have these values, we can put it into the law of sines. So that becomes AD over sine 23 degrees equals to 200 over sine 32 degrees. Now for the last step, we make AD the subject. We do this by timesing the RHS with sine 23 degrees. If we solve this, it would become AD equals to 200 times sine 23 over sine 32, which is also the RHS of the question. Now for our last example for the day. The question asks to find the ratio between x and y, which we can find using the sine rule. Let's start by putting the sides and the angle into the sine rule formula. Because we want x over y, we times both sides by 1 over y. After we cancel out the y's, we get x over y times sine 60 degrees equals to 1 over sine 45 degrees. If we move the sine 60 to the right hand side, we get x over y equals to sine 60 degrees over sine 45 degrees. Because sine 60 degrees and sine 45 degrees are exact values, it would become root 3 over 2 times the reciprocal of sine 45, which is root 2 over 1, and this results in root 6 over 2. See you next week where we'll learn about the cosine rule.